let's just take a look at the mechanics of transaction logs, because it's similar in some ways, but it's also different in some ways. So to start out with, what's similar? Simple. We still store data in the usable format. In that, we create a disk and we put data on it and we snapshot it. We get the data onto that disk by mounting the disk to the server and then copying data onto it. That's where the similarities end, though. The way that we manage retention is very different, and the contents of those files is a little bit different. And I'll explain what I mean here. So the process for transaction logs always starts out with the Actifio connector, of course, right? You already have it there if you're doing your database backups. When we run our first transaction log job, the system will look at what you've defined in the policy as the retention period for logs. And rather than looking at the production disks, so one thing I didn't really mention very much on the previous slide is when we're creating these disks to present to the server for the first time, how do we know how big to make them? And the answer is we look at the production disks. So if you have an MDF, an NDF, and an LDF file on 3 different volumes, and so we're going to create 3 different disks, we're looking for each one at the corresponding production disk size and making it the same size plus a little bit of buffer space. Now, this is a thin provision disk, which means even though you might have chosen to back up just one database instead of all of them, and therefore maybe you wouldn't need it to be as large as the whole source disk, it does no harm to make it that large because it's not consuming any extra space. Now, on the log side, that method is very different. We have to look at the retention period because instead of having one copy of one backup and then just keeping snapshots of it, that becomes very complicated if you want to use the logs. Now you have to mount back a whole bunch of disks, a whole bunch of snapshots, if you're going to roll to a certain point in time that spans a whole bunch of different transaction log backup jobs. So we create one disk, and it's as large as is needed for your full retention. So you might even say, I'm only keeping in my snapshot pool database backups for 2 days, but I want to keep logs for 7 days so that I can use them in conjunction with data that I've put into the dedupe pool or that I've put into my OnVault pool, the object storage pool. And so we create that single disk large enough to handle the full retention. What we then do is we actually kick off a traditional SQL Server transaction log backup, and we point it at the Actifio mounted disk. So there's really no magic there other than the fact that it's using a storage protocol for the data movement, and it's SQL Server doing the data movement rather than our Actifio connector. The connector is just initiating the transaction log backup. Now, one thing that we've put into the product that is kind of an important thing to understand, it's one of the things that, hey, just make it work that we did to achieve that. If you're familiar with transaction logs and backups, you also know that you cannot run a transaction log backup on a new database until you've done an actual full backup of it. Yet with Actifio, we never really do a full backup of it in SQL Server terms. We always do a VSS backup. You can see the log entry in SQL Server from our database backup jobs that a backup occurred, but it doesn't do the same style of backup that initiates the log sequence numbers in a way that you can do a transaction log backup. And so when you run a transaction log backup with Actifio on a database that has never had a real traditional full backup done, what we did to make it, quote unquote, just work was we created some code that runs a full backup. It runs it to the built-in device on every Windows server. That's the equivalent of a Linux dev null. It runs it to :null, which means it actually forces SQL Server to read the entire database files and write them to null, meaning throw away all of the data. But because it's gone through the process of reading it, it initiates all of the pointers and all of the flags that are necessary to enable transaction log backups. So just a word of caution there. If you do have a database that has never had a full backup and a real full backup, and you want to run transaction log backups on it, the first time you run the transaction log backups, you might see more read activity than you would have expected, and it might take a little longer than you would have expected for a transaction log backup. And that would be when it's doing this fake full to null in order to initiate those pointers. So after we run the transaction log backup, the next thing that we have to do is manage retention, because I already told you this disk is large enough to handle the full retention. So we're putting data onto it. We also have to take data off of it. So the connector, after it validates that your transaction log backup has been successful, it looks onto those mounted disks and it finds any logs that are beyond the retention period, and it deletes the files. Now, when I say the files, these are the files you're accustomed to seeing with SQL Server. They're .trn files. They're nothing special. We're not doing any bitmap tracking or magic with this. They're just transaction log files. So we run a transaction log backup to our disk. We delete the older logs that are beyond expiration on the disk. Then we unmount the disk from the server, just like we do with databases. And then we take a snapshot of it. Now, this snapshot is for integrity. And what I mean by that is, if you have a job that, say, fails for some reason, well, part of our failure process is to roll back the changes. Well, the way that we do that is by having a snapshot of the last successful job. And we can use that to roll back the full disk to look like the last successful point in time. So that means that on every job, as we repeat over and over and over again, we take one new snapshot at the end of the job and then delete the one from the previous point in time, because we don't want to keep that one. That will have data that's beyond its expiration on it. We're not using snapshots to manage expiration with transaction logs. We are for database backups, but not for transaction logs. Now, this approach has a really nice benefit to it, because when you want to access the data, all we have to do is mount the database disks to the target server. And if you chose to do a point-in-time recovery, we only have to mount one additional disk, and it has the full range of transaction logs on there that are then used to roll the database to the point in time that you've specified. So that's our integration with transaction logs.
Thank you for joining us for another YouTube Tech Tip video. If you like the content you're seeing on this channel, please remember to like the video, subscribe to the channel, and turn on notifications so you will be alerted to any future content.